Hi, Assalamualaikum everyone. You are with me, Teacher Wan. Today, we are going to cover topic absolute values. I'm pretty sure that you have watched the videos by Mr. Lam. He had covered topic equations and video by Puan Zainah, INEQUALITIES. At the end of the lesson, you must be able to first state the properties of absolute values, and of course you must be able to solve the absolute equation. Okay, first of all, let's have a look at the definition of absolute values itself. Okay, absolute values denoted by the modulus of x. Okay, and it means that x can be either positive or x can be either negative. Imagine that absolute values is like a magic wand. If we put in positive values, it will give us positive. But if we put negative values, it will give us positive. What if we have absolute values of an equation? It means that absolute values of x plus 5 will give us x plus 5 and negative x plus 5. Therefore, we will end up with two values of x. Absolute value has more to do with the idea of magnitude you travel. What is magnitude? Magnitude is basically amount, strength or length which is opposed to direction in vector. For example, Sarah drove her car from Kuala Lumpur to Kuala Pilah with distance 70 km. While driving, she stops at RNR Seremban and accidentally left her purse. As soon as she arrived in Kuala Pilah, then only she remembered her purse was left at the toilet. Then she rushed back to RNR Seremban and found her wallet. She then headed back to Kuala Pilah. Can you tell me what is the total distance that Sarah has traveled? Yes, 70 km plus negative 40 km, but we've put absolute values here, and plus with 40 km. So total up will give us 150 km. Properties of the absolute values. The first one, absolute values of a number is always positive or equals 0. For example, if we have a equals to 10, therefore absolute values of 10 is 10, which is greater and equal 0. If we have a equals to 0, so absolute values 0 will give us 0, which is equals to 0. Okay. If a is negative number, for example, negative 10, so absolute values of negative 10 will give us positive number, which is 10, which is also greater and equal 0. Let's look at the next properties. The absolute values of a number is equal its negative number which has absolute values on it. For example, okay, just now, absolute values of 10 is equivalent to absolute values of negative 10, because absolute values of negative 10 is 10. Alright, let's look at the third properties. Okay, the summation of a plus b is equal b plus a. Okay, for example, 1 is positive, let's say a equals to 2, and b, let's say, negative 3. Okay, so 2 plus negative 3 will give us, if we put absolute values, it will give us negative 1, which is equivalent to 1. And if we do the same but in different order, which is negative 3 first and then plus with a, our a is 2 here. Okay, so negative 3 plus 2 is negative 1, but when we look at values, it will give us 1. So it shows that it has same values here. Okay, next. A minus b is equals to b minus a. Okay, we stick to the number above here just now. A is 2 and b is negative 3. Okay, if just now we find the summation or addition, now we will do the subtraction. So 2 minus with negative 3. Okay, don't forget the absolute value sign. So 2 negative negative becoming plus, 2 plus 3 becoming 5. Okay, 5 absolute values is 5. Okay, how about we change the order, which is where negative 3 minus 2 this time. Okay, negative 3 minus 2 will give us negative 5. But if we put the absolute values, it will give us 5. So it's proof that it will give the same answer no matter what's the order. Okay, we have seen for addition and subtraction. Now let's look at the multiplication properties of absolute values. Again, if let's say our A is 2 again and our B is negative 3 again, yeah? Okay, 2 times negative 3 and the absolute values of the number just now, so it gives us negative 6. Since we have the absolute value here, so it gives us positive 6. Okay, let's check if we absolute values the integers one by one. Okay, so let's say absolute values 2, which is our A, and absolute values of negative 3. So we give 2 times 3, which also gives us 6. Okay, so yeah, it's proven it's equal even for the multiplication. Okay, and the last one, let's look at the fraction. Okay, for example, again we take A as A as 2 and B is negative 3. So okay, what if we take a larger number? For example, A equals to 6 and B equals to negative 10. Okay, so 6 over negative 10, the absolute values of the number. Okay, 6 over negative 10 will give us 3 over negative 5, and we put the absolute values, it will give us 3 over 5. Same goes to if we absolute values each number here, which is absolute value 6 over absolute values negative 10. It will give us 6 over 10. And finally, 3 over 5. Let's solve the following equation. Given to us absolute values x equals to 3. So it means that x can be 3 or x can be negative 3. So our answer can be written as this. Second example, given to us absolute values 3x plus 5 equals to 4. By using definition, we will get 3x plus 5 equals to positive 4 and 3x plus 5 equals to negative 4. Okay, we calculate the first part. So we bring 5 to the right. So 4 minus 5, we get negative 1 over 3. Then the second part, we bring 5 to the right, becoming negative 4 minus 5 over 3. And we will get x equals to negative 9 over 3, we get negative 3. Therefore, we can write our answer like this. X equals to negative 3 or negative 1 over 3. I will let you try this example yourself. Happy trying! If just now we have a look at the linear absolute values function, now we are going to look at the rational absolute values function. Given to us 2 over x minus 1 equals to 8. By using definition, it's equals to 2 over x minus 1 equals to positive 8 and the other one is negative 8. Let's calculate the first part on the left. Okay, we bring x minus 1 to the right, becoming 8x minus 8 equals to 2, and then 8 plus 2 equals to 10. 10 over 8 will give us 5 over 4. For the second part on the right, okay, as usual, we bring the denominator to the right, so becoming negative 8x plus 8 equals to 2. And then we bring 2 to the left, 8 minus 2, becoming 6. And then x equals to 6 over 8 gives us 3 over 4. Therefore, the answer in a solution set form is 3 over 4 or 5 over 4. Make sure that you write the smaller number first. Okay, don't forget to try this question. If just now we have a look at the absolute values for linear and rational function, this time we are going to look at the absolute values of quadratic function where the x has power 2. Okay, so by using definition, x squared minus 6 equals to 3 or negative 3. Okay, we will solve on the first part. So negative 6 bring to the right will give us 3 plus 6 is 9. Okay, bear in mind it is x squared, therefore it will give us two answers, which is x equals to positive and negative 3. Okay, on the right hand side, we bring negative 6 to the right. Okay, will give us 3. And again, x squared equals to 3. We want to get rid of the square, therefore we square root both sides. It will give us positive, negative set 3. Therefore, we can write our answer in a form of solution set like this. Okay, bear in mind that we're going to write the smaller number first. Okay, what if the question given to us absolute values x plus 5 equals to negative 3? Negative. Okay? It doesn't have solution because the absolute value of a number is never be a negative. Okay? The absolute values of a function will always give us positive. Okay, as usual, I'll let you try this question. Okay, let's look further for rational function for absolute values. Okay, given to us absolute values of x plus 1 over x minus 7 equals to 5. By using definition, it is equals to 5 or negative 5. Okay, we solve on the left part. Okay, x minus 7 we bring to the right, so we expand, it becoming 5x minus 35. And then 5 we bring to the left, so it becoming x minus 5 give us negative 4. And 1 to the right, negative 35 minus 1 give us negative 36. And 36 over 4 is equals to 9. The second part here, as usual, x minus 7 we bring to the right and then we expand, it becoming negative 5x plus 35, and then we solve 6x because negative 5 we bring to the left. Okay, 6x equals to 34, therefore x equals to 34 over 6. Alright, so let's look at the next example. If just now we have a look at the linear, quadratic, and rational absolute function. Now, this time, it's a linear function, but we have another unknown without absolute. Okay? So, let's look what's the difference in the calculation. Okay? So, by using definition again, x minus 3 equals to the positive function here. And x minus 3 equals to a negative function, 13 minus 3x. Okay, we solve as usual for the first part. Okay, negative 3x we bring to the left, it becoming x plus 3x, 4x, and then 13 plus 3 give us 16. 16 over 4 will give us x equals to 4. And for the second part here, we expand the negative. Careful, yeah, negative times negative becoming positive. Okay, 3x minus x, 2x, negative 3 plus 13 give us 10. Therefore, x equals to 5. Now, we have two answers, but we have to check if we substitute the x values, is it going to give us the same values on the left and the right hand side? Okay, if there is any variable without modulus, we have to test the answer. Okay, we test on the left hand side, x equals to 4. Okay, we substitute 4 minus 3 give us 1 on the left hand side, and then 13 minus 3 times the x values here 4, 13 minus 12 give us 1. So left hand side equals the right hand side. Let's check when x equal to 5. Okay, we substitute 5 in our equation. 5 minus 3 we get 2. 13 minus 3 times 5 we get negative 2. Since left hand side is not equal to the right hand side, we cannot take x as our answer. Therefore, we only have one value of x, which is 4. That's it for today. I'll see you on the next video. Bye!